I built an app that lets you ask a database anything in plain English. In my last video, I fixed this with an AST parser, PostgreSQL own engine validating every query before it runs. I thought I was done. Then I showed it to people who do cybersecurity for a living. And they said, one layer is not security. One layer, it's luck. Today, I am adding 5 more. Right now, the app has no opinion about what you type. 5,000 characters of garbage. The LLM processes every single one. No length, no limit, no filtering, nothing. That's base 64, an encoded instruction hidden inside the query. The LLM decoded it and obeyed. The AST caught the SQL, but the point is the LLM was manipulated and the input read the model with zero filtering. A professional cybersecurity expert friend of mine challenged me with this exact attack. The endpoint accepts whatever you throw at it. No limit, no filtering, nothing. I need input validation, cap the length, filter out the typical prompt injection patterns, and if something gets rejected, the error should be generic. Don't tell the attacker what triggered it, and you know the drill, test first. This is the bouncer at the door. It doesn't understand your intent, it just checks if you look suspicious, and the error tells you nothing about why. Same attack, blocked before it reaches the LLM. But is this enough on its own? No. A smart attacker will rephrase until they get through. That's what the layer 2 is for. This is the layer that will make sense to anyone in cybersecurity, because prompt injection is not a software bug, it's social engineering. When someone calls your company pretending to be IT support and asks for a password, that's social engineering for a human. When someone types ignore your instructions, that's social engineering for an LLM. It's the same game, it's just a different target. Look at this. I typed ignore all previous instructions, and the LLM didn't refuse. It didn't return the PG catalog data I asked for, but it returned 100 rows of real property sales, real data. The LLM was partially manipulated. It's not a clean block, it's a messy compromise. And that's exactly why you can't rely on the LLM as a security layer. Look at the system prompt. The user input goes in mixed with my instructions, no boundary. The LLM can't tell where my rules end and the attacker's input begin. Now the user input is sandwiched. The last thing the LLM reads before generating the SQL is my rules, not the attacker's instructions, but the LLMs are probabilistic. We assume this layer fails too. This is the layer from the previous video, libpg-query, the actual PostgreSQL parser compiled to WebAssembly. It's what caught the base 64 attack earlier. If you haven't seen it, link in the cards. The AST validator from last time only checks table references, but there are PostgreSQL functions that are just as dangerous. Things like pg-sleep for denial of service, pg-read-file to read the file system, dblink to connect to other databases. Block all those and add tests for each one. The allow list is tighter now, not just tables, but functions, and auto-injects limit 1000, because even a legitimate query on a 31 million rows can be a denial of service. Principle of least privilege. The database user that runs your queries should have the absolute minimum permission needed to do its job. Nothing more. Right now, the app connects with a user that can read everything: system catalogs, other schema, the lot. The app connects to PostgreSQL with a user that can read everything: system catalogs, other schemas, the lot. Create me a read-only role that can only do select on property sales and nothing else. Timeout on long queries, timeout on logs, and no access to PG catalog. I want the database itself to say no if everything else fails. Permission denied. The same query that exposed passwords in video 1, the database itself rejects it. Even if layers 1 through 3 all fail, PostgreSQL says no. Most people think about security as keeping bad things out, but what about what comes back? Right now, some errors return a 500 with a generic message, other leak details, a raw database error can expose your table structure, your schemas, your connection. That's free reconnaissance for the next attack. Right now, if something goes wrong, the raw PostgreSQL error goes straight to the client. That's giving away information for free. Catch all the errors, give the user a generic message, but log the real error server-side with everything, what the query failed, why, where it came from. I need to know what happened. They don't. Also cap the results. I don't want anyone pulling 31 million rows in one go. Tests first. The attacker sees nothing. My logs see everything. Blocking an attack means nothing if you don't know it happened. Add a helmet, rate limiting and cores to the server. The basics for production, no more than 20 requests per minute, and only the frontend should be able to talk to the API. Tests first. 15 requests per minute. Request 16 gets locked out. An attacker brute forcing prompt injection gets 15 attempts, and then they're done. None of this is glamorous, it won't be on the thumbnail, but this is the difference between a demo and a production system. All 6 layers active. Let's replay the attacks. Caught at layer 1. Input validation. The words ignore all previous instructions hit the block list. It didn't even reach the LLM. The base 64 that tricked the LLM earlier, layer 1 catches it. The encoding pattern blocked. 3 layers deep. No suspicious keywords, so input validation let it through. Sounds like a legitimate question. So the prompt hardened it, let it through. The LLM generated a full select against PG catalog, but the AST parsers caught it. And even if it hadn't, layer 4 would have. The database user doesn't have permissions to read that table. 4 independent systems, any one of which stops this attack. That's defense in depth. A real question sails right through. 6 layers of security, 0 frictions for actual users. 6th layer. But I am not going to tell you this is production ready. There are things I haven't built yet. Authentication. Right now, anyone can reach this API and can query it. In production, you need tokens, you need sessions, you need per user rate limiting. Second, logging and alerting. I have server-side logs, but no dashboard. I don't get notified when someone's proving my API. Third, a web application firewall in front of everything. The point isn't that a 6th layer is enough. The point is that 1 layer, it's never enough. You are not building a wall. You are stacking probabilities in your favor. Everyone's building LLM apps. Very few are hardening them, and the attacks are already happening. Security researchers are actively proving LLM-powered systems right now. The code for all 6 layers is in the description. The dataset is free. You can have this running tonight. And here is what I believe. Everyone can build the same system with the same tools. The software is cheap. What makes the difference is how you engineer your prompts, your context, your security layers. The intellectual property is in the thinking, is not in the code. I am Javi, the LLM Whisperer, 21 years of engineering, now orchestrating AI agents on real projects. If you want to see how that actually works, subscribe and I'll see you in the next one. Adiós!